At the beginning of this chapter, we talked about quadratic functions and the parent function f of x is equal to x squared. After, we looked at quadratic functions of the form f of x is equal to ax squared. Depending on the value and sign of a, we said that the sign of a causes the graph to either open upward or open downward, while the value of b causes either vertical shrink or vertical stretch to the graph of ax squared. Also, we looked at transformations of quadratic functions that were binomials. They were of the form f of x is equal to ax squared plus c, and depending on the sign of c, we said that they cause either a vertical translation, c units up or c units down. In this lesson, we will look at quadratic functions that are of the form f of x is equal to ax squared plus bx plus c. So take note that this is now a trinomial. There are instances, however, when c is equal to 0 and the resulting quadratic function will again be a binomial. So one important skill that we have to know before we move on to the next slides is how to find the values of a, b, and c. Take note that if your quadratic function is arranged in standard form, your a is the coefficient of x squared, your b is the coefficient of x, and c is the constant. So another way to explain it is a is the coefficient of your quadratic term, b is the coefficient of your linear term, and c is the constant. Again, let me emphasize that in some of the examples today, c may be equal to 0. So in other words, you only have a form f of x is equal to ax squared plus bx. So first, let's study how to find the axis of symmetry and vertex of the graph of a certain function. In this example, we see a binomial because the value of c is equal to 0. So we said earlier that it's important to know what a and b are. So here, the value of your a is 2, while the value of your b is -8. So the b takes its sign. So first, find the axis of symmetry. We have to use a new formula that I'm going to introduce here. And the formula is given by x is equal to -b over 2a. You have to memorize this. Sometimes I read it in a different way and I say x is equal to the opposite of b over 2a. So based on our example, since b is -8, I'm going to copy or write its opposite, which is 8, all over 2 times a, but the value of a is 2, so 2 times 2. So if I solve for the final answer, it will become 8 divided by 4, which is equal to 2. So therefore, the axis of symmetry is x is 2. So on the right, you will see that I've started to graph already. The red dotted line is the axis of symmetry. So that's 1, 2 to the right, x is equal to 2. And I know that the vertex is somewhere here because the axis of symmetry is the one that divides the graph into 2 equal halves. However, I need to know whether the vertex is up here above the x-axis or maybe down here below the x-axis, or maybe it's on the x-axis itself. So how am I going to find that? So step 2 here says find the vertex by substituting x into the equation to find y. So let me write down the function that we're looking at. It's f of x is equal to 2x squared minus 8x. So if I substitute 2, I get f of 2 is equal to 2 times 2 squared minus 8 times 2. So solving further, this is 2 to the second power, which is 4. I multiply it to the 2, which becomes 8, minus 8 times 2 is 16. So that means f of 2 is equal to -8. So that means along your axis of symmetry, the vertex is given by +2, That's for the axis of symmetry that we get from step 1. And then the y coordinate is -8. So let me plot the point. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the vertex must be somewhere here. So that's the vertex 2, -8. So we're going to leave this example as is for now. I'm not going to complete the graph yet because I want to show you 2 more examples on how to find the vertex. In this example, we're given f of x is equal to 3x squared plus 2x. And again, just like what we did previously, we're going to find the axis of symmetry. And then after, we're going to substitute what we get into the function to find the vertex. So in this example, the value of your a is given by the number before the x squared, and the value of your b is the coefficient of x. So if you're going to substitute here into the formula, it says opposite of b, so 2 will turn negative, over 2 times the value of a, which is 3, so that will give us -2 over 6, which is equal to -1/3. So yes, it's possible you could get fractions. Now, how are you going to get or substitute that into the equation to find the vertex? So if x is equal to -1/3, we copy f of x here, which is 3x squared plus 2x. Now substituting x equals -1/3, we get 3 times -1/3 squared plus 2 times -1/3. So f of -1/3 is equal to 3 times, this will become 1 over 9 because -1 squared is 1, and then 3 squared will be equal to 9. And then positive times negative will become negative, so this will become -2/3. Solving further, 3 times 1 is 3 over 9, so this will become 3 over 9 minus 2/3. But scroll this down. Okay, 3 over 9 can be reduced as 1/3 and then subtract 2/3. So your final answer here will become -1/3. So the vertex of this function will be at -1/3, -1/3. Or it could also be changed into decimals, which will be -0.3, -0.3, which is easier when you're graphing because you could see where it is on the x-axis. Okay, on our third example, we have a trinomial, so it has a value of c. And again, it's important to note what a, b, and c are. So a is 2, b is -8, while c is 6. Well, in finding the axis of symmetry, does the value of c matter? Well, no. But later on, when we find other parts of the graph, the value of c will have an effect on our answer. So going back here, let's substitute again the value of b. So we get the opposite of b, which is 8 now, because it was originally -8, so we do the opposite. You get +8, and then 2 times a, which is 2. So this will become 8 over 4, which will again give us 2. Now, since our function has a c, the value of y will not be the same as the one we previously got when we also had x equals 2 as our axis of symmetry. So f of 2 now will become 2 times 2 squared. So again, I'm following this function over here, minus 8 times 2 plus 6. So solving further, we get f of 2 is equal to 2 squared is 4, times 2 is 8, minus 16 plus 6. So let's get the final answer now. 8 minus 16 is -8. And then when you add 6, so this will become -2. So that means the vertex is at positive 2 from your axis of symmetry, and then the y coordinate is negative 2. So again, we're going to leave it here for now, and then we will go back to how to find the other parts of the parabola later on. After you do the next activity, which is how to find the axis of symmetry and the vertex. So you will use what we learned in this 3 slides to answer the 6 questions. Good luck.